Hello guys, this is our computer vision project, Banana Ripeness Detector. For our group members, we have me, myself, Akwisu Zukunchai, and my friend Keen Napon Namshawat. For the problem statement, the core challenges is we need to minimize food waste via a precise ripeness classification. As you can see from the pictures, there's a road arm, so we will make it autonomous monitoring. Imagine we have a banana farm in March, right? Our system can use CSV to detect the banana ripeness and classify the banana into the each categories. For our solution, we will transitioning from RGB to HV, as you can see from the pictures on the right, and isolating hue chroma from value luma to counter unpredictable module lighting. And lastly, we have to ensure zero human intervention reliable with a face detection module. As you can see, there's no human face or anything detected. So to make sure that the data we are collecting are 100% from the bananas.
So for our logical architecture systems, so we have mainly five processes. So for the first one, our pipeline begins with input and pre-processing. So where we define a specific region of interest or RI box because we need to account for unpredictable environment. We perform lighting correction by applying CLAHE directly to the HSV value channel. Next, we move to color masking using a finely tuned HSV parameter, which we classify unripe or green bananas using a hue range of 35 to 85 and ripe bananas from with a hue of 20 to 34 and overripe or brown bananas with hue of 0 to 19 across these categories. The value channel is kept between 40 and 255 for green and yellow stages, but lowered to 0 to 120 for detecting brown. To ensure that all the readings are clean, we apply noise filtering via morphological open and close operation using a 7 by 7 kernel. And finally, the system processes this data to output a percentage calculation and a definitive ripeness classification. So for the system resilience and edge cases and telemetry, so for our system to be reliable without human intervention, we focus heavily on system resilience. So we implemented a dynamic anomaly injection during testing. So we found that human skins can inadvertently trigger false overripe bananas readings. So our solution was to integrate a HAAR cascade face detection, which dynamically tracks faces in the frame and cancels the false reading, briefly displaying a waiting for banana prompt instead. So in terms of the data collection, we also built in a live data telemetry. So the user interface features a custom GUI complete with a live Kinter stat percentage bar. Behind the scene, the backend is continuously logging the timestamps and exact color percentage to a CSV file. So this isn't for immediate grading, but it's also enable long-term agricultural trend analysis. So for our system scalability, we're looking to the next frontier. Our focus shifts to system scalability. So the first major step is deep learning integration. So we can plan to transition away from traditional CSV to move toward something like a model of YOLO V8 as it provides lightweights and also real-life object detection. The second step is computing deployment, which we intend to port our current Python architecture to directly embedded physical devices. So our target hardware of this phase include a Raspberry Pi or NVIDIA Jetson Nano, which our ultimate goal is to physically integrate the hardware onto automated greenhouses conveyors, which is a perfect application for closed loop environments like deep space or Mars-based space station. Thank you for listening. So now I will show you the uh, actual product. So as you can see here, this is the code that we are using. So let's start it. It's all written in Python. And okay, so this is our software. It also has a GUI. So let's start the camera and wait for it to load. Okay, so as you can see here, it's detecting my face. So ไม่ตัดออกว่ะปกติมันต้องตัดหน้าออกเนี่ยมันจะขึ้นแดงๆyeah, as you can see here, it's saying waiting for banana because it's detecting my face. So for example, if I have a yellow banana, if I have a yellow banana, it can detect that it's a ripe yellow, as you can see. Or if I have a green banana, if I have a green banana, it's gonna say that it's like ripe yellow green. Or here is a ripe to brown banana. It can say overripe or brown. So like a very brown banana, it's gonna say it's very ripe. We can also stop the camera and then upload the image from our computer. Yeah, as you can see. And we can also log the data to a CSV file, which we can then open from our computer. Right here. As you can see, there's a timestamp that says what the percentages of the hue is. Okay. Thank you for listening to our project.